Technology, and especially the robotic field, evolves very quickly, and it has an impact in all kinds of fields. As an industrial designer, I can observe a positive evolution, mostly because it creates new challenges and design opportunities around me. Since 1 year ago, I started working for Verity Studio. Verity Studio is the world-leading provider of indoors drone shows. We build and develop drones that are autonomous. Thanks to algorithms implemented in the electronics and an indoor GPS system, these drones know very precisely where they are in a delimited space, meaning a large number of drones can fly together a programmed choreography. With this technology, Verity Studio has made a first collaboration with Cirque du Soleil, a short movie called Sparked, where you see our drones, dressed as lampshades, performing with a human actor. Since then, they have gone even further with this incredible Broadway show called Par Amour and created by Cirque du Soleil. Here again, the drones, dressed as lampshades, performed in front of a live audience during 1 year. And in total, they have done 7,000 takes-off, flights, and landings. And after these two successful collaborations, Verity Studio decided to grow its creative team to develop this research on costume drones. And for this very specific research, they had to invent the new profession of drone costume designer. And here I am. It's an amazing opportunity for a designer, arriving in a completely new field where nothing exists except the lampshades. It was an open field with the possibility to invent a new dream and a new kind of poetry. But where to start? What do you want to see on a drone? What is the effect you can get by adding colors or shape on a flying machine? So I first had to create my own creative process. And it starts by looking at everything surrounding us to find some inspiration, from the theater costumes to flying objects, or the birds' courtships or underwater creature. And beside this visual research, one of the major parts of my creative process is to create small prototypes. It helps me understanding the structure or the color or movement effects I could get in a costume. As the final costumes are quite big, it's easier for me to start exploring in a smaller scale. So through these small iterations, I can already observe some details or some movements that I find interesting to use in a future costume. Also, this empirical research is very important in my process. So it often happens that I start playing intuitively with the material without any specific goal in mind, and that it leads to a result I wasn't expecting at the beginning. So this is an example of this process. I once started playing with mirror surfaces because I had in mind creating a giant flying disco ball. And by playing with the material, I realized it was interesting to play with the reflections, not only on the wall and ceiling as you have with a normal disco ball, but on the costume itself. So by engraving the plastic mirror surfaces and according to their orientation, I was able to create different light patterns that I found interesting. So the result is this very simple costume. And the wings on the side are covered by mirror surfaces, and they are slightly bent. So when you project light on it, you will get reflections on the white cylinder you see in the middle. So at the end, you will have the costume moving according to the drone's choreography, but also offering a constantly changing appearance thanks to the patterns and the light projection on the costume. And I think it gives a new dimension to the costume. So, of course, one part of the drone costume designer's job is the visual and aesthetic research, but strongly linked to it is the technical aspects. So with first flight test, and by discussing with the engineers of the company, I quickly realized I had to deal with many physical constraints. And I'm going to tell you about a few of them. So first logic one is the aerodynamic. Each costume is going to create new drag and lift forces for the drones that need to be accounted for. So when I create a costume, I always have to make sure it won't impact the drone's trajectory. So the costume's inertia is equally central to our design because it can modify the drone's movements, for example, its smoothness or its agility. Another constraint is the path of the airflow. As you can see on this video where we tested a costume's prototype, this airflow is very strong, but it can also be counterintuitive sometimes. For example, if a costume is too close from the propellers, it can be sucked by the propellers and lead to a loss of control. So I always have to make sure there is a good distance between the propellers and the costume, and that the costume won't interfere with the airflow produced by the drone. And the last constraint I'd like to talk about is the weight limits. So our drones are about 80 centimeters of diameter, and the maximum weight we can have on the drones is 250 grams. So it's not a lot. And it means that any single component I want to add on the costume has to be very precisely calculated. So each costume is a new challenge from the design perspective, but also from the engineer one. It's a constant collaboration between the two fields, and this costume illustrates perfectly this collaboration. So it's based on the resonance effects, meaning that the drone, by flying at the right oscillations frequency, is going to excite the costume movement, giving it a jellyfish aspect while flying. The first time I designed this costume and flew it, it didn't work. And I thought it was a design problem. Like, the movement of the drones of the costume wasn't the one I expected. And I was ready to fix it. But then the engineer stopped me, and they explained me that it's not a design problem. It's just about the drone's movements. We should use the resonance effect to actuate a movement in the costume. Because resonance is often encountered in engineering, but most of the time with a negative connotation, as you don't want to have vibration transmitted in the structure surrounding the drone. But here, it was more than useful for us. So as we've just seen, the link between the drone and the choreography and the costume is very important. Most of the time, a costume is developed for very specific movements. So here, this costume was made to play with large up and down movements, and I wanted to have a transformation in the costume. So the white parts you see are made to catch the air, and they are all connected with thin carbon rods braided together. At the end, this costume is very lightweight. It's about 150 grams. And building such a functional costume can take a long time. So every time I can, I try to find a way to test the costume by hand. So by flying it the first time, I don't take the risk of damaging it. So here, I could test the movement of the drone. And this part of the process is very important for me because it helps me iterating quickly on the design, decoupling from the technical aspects, such as calculating the drone's inertia or calibrating the first flight test of the drone. And this costume passed what I call the low-tech flight, and this is how it looks like when it flies for real this time with a real drone. The last costume I'd like to talk about is based on this opening and closing movements, depending on if the drone is flying or not. So this is how it works. The blue surface you see under the drone is going to catch the air produced by the drone. And as it's related by wires to the costume, it's going to actuate this movement of opening and closing. Each time the drone takes off, the costume closes, and each time the drones land, the costume opens. And this was the beginning of a research based on the same concept of opening flowers. Here, we imagine a permanent performance in an airport at the baggage claim area. You would have these giant flowers flying over people and landing on specific platform to recharge, allowing the people to come closer to the costume and observe them. And each time the costume would take off this platform, the drone would take off this platform, the costume would blossom as a flower. And I think this project of permanent performance in a public space gives a new dimension of what we can imagine with autonomous drones. So a few years ago, it wouldn't have been possible to imagine such a profession of drone costume designer. But thanks to the development of this technology, a new field is now born, and it keeps evolving. At Verity Studio, for example, we are now working with new types of flying machines, small drones that are able to fly in a large number to create a swarm effect and play with light. And if you want to see them, You have the possibility to see them at the Metallica band concerts, which are on tour now everywhere in the world. And this is the first autonomous drone swap performance in the world in a major touring act. So after 1 year of research, I still have the feeling there are many things to explore and many things to learn from this technology. And I hope for the moment we have inspired you to imagine the infinite and great possibilities we have. Thank you.